Now here the relationship between the zeros and the coefficients. So the general form of quadratic polynomial is ax squared plus bx plus c, right? When alpha and beta are the zeros of the quadratic polynomial, we can express the same polynomial as x minus alpha, x minus beta, isn't it? Why alpha beta here? What is this alpha beta and all? They are nothing but alphabets, like Greek and Latin alphabets. Okay. They are from different language because those people derived all those things. That is why they use their one. Okay. Here, when they say zeros, it can be represented as linear factors consisting of x minus alpha and x minus beta. Got it? But here there is a catch that either it will be a constant multiple of anything also to generalize this. Okay. That is why we are using the value k. Meaning what? It's a constant multiple of any other thing because a polynomial multiplied with any number still have its own zeros. It won't change. Okay. For example, take this one. When you see, it is difficult to imagine with alpha, beta and all means. Look at this one, x square minus 2x plus 1. This is a quadratic polynomial. Okay. In this, you multiply everything with the 2. 2x square minus 4x plus 2. Still is a quadratic polynomial. When 1 is a 0 of this polynomial, for multiplication with 2 also 1 is a 0. Is it? By multiplication with the 3 also what? Multiplication with the 3 also 1 is a 0. So to denote this one only, we use the value k. Okay. Now here, you just multiply this using the formula that here ax square plus bx plus c is there, right? That is equal to k into, you multiply everything inside. You know formula x minus a into x minus b, that is x square minus a plus b into x plus ab. Remember that formula. And from this, we can equate the coefficients. Equating coefficients on both sides, we may get, here coefficient of x will be what? Better I will write the product. So it is kx square minus alpha plus beta into kx plus k alpha beta. I multiplied that k inside. Equating the coefficient, yesterday we have seen what is coefficient, right? So here coefficient of x square is a. That is equals to, their coefficient of x square is k. Got it? Likewise, here coefficient of x is what? B. That is equals to minus alpha plus beta into k. Correct? Coefficient means whoever accompanies x, except x we should say. Okay. Likewise, the value of c is what? K alpha beta. Got it? And from this, we can get sum and the product of roots. We mark this as 1, 2, and 3. The sum of the roots. Who are all our roots? Alpha and beta are the roots of the equation. So in this, sum of the roots means alpha plus beta. So from 2 and 1, what we can get? This alpha plus beta. That is nothing but sum of the roots. Sum of zeros actually. So this negative sign transposed to other side, minus b by k. What is k actually? Minus b by e. Got it? Likewise, the product of roots. product of zeros, that is alpha beta. So from 3 and 1, what we can say is alpha beta, when you equate, what we get is C by K, so that is C by A. Okay, these two are very important formula, but I prefer not to use this one as a formula. Why? Because the actual formula from this is minus coefficient of x divided by coefficient of x square. Here constant term by coefficient of x square. So only this formula you should use in your exam. Why I am saying? Because they may swap the variables. So what will you say about sum and the product of the zeros for this equation? I'll erase this one. Have you noted down this? So here the sum and product of this equation, like bx square plus ax plus c. Is this still minus b by a? No. When you are going with this formula, this one you may get confused. When you are going with this formula only, you will get your answers correctly. So don't go by minus b by a, c by a and all. For this format, this is the formula. So concept wise, this is the formula. You should write in paper as well. Got it? This is about relationship between roots and coefficients. See, I have related the coefficients with the roots. A, B, C and all coefficients. The roots are alpha, beta. We have related those things. That is it. Got it? Any doubts? Okay, just note this down. We'll move on to the next one. We'll see some examples on this.